So what you see in general, guys, here, what you see here is indeed the relation when we're talking about how the operating system, what's an operating system, what is hardware, how it's related with the operating system and with the programs we're using and so on and so forth, and in the end, obviously, the user. Well, I always have this diagram in mind. We did it already a couple of times. It's important you guys to go again and to understand it, since we're gonna go through the today we're gonna go more in depth into the um, into the virtualization itself. So I'll show you the diagram now. Here it is. See. So um, when we're talking about the components which are doing this, the today's computing, uh, how they defined it, I would say there are three layers. We show four layers here from 0 to 3, since we start always counting from 0 in IT, it's, it's an exact science. So but we're talking majorly for three layers: the layer of the hardware, which is at the bottom, 0; the layer of the software, which actually in my schema here number 1 and number 2; and the layer of the user, who actually uses all of this. Now, without the user, none of this will be needed. So basically, user is who is defining what is needed at the moment, right? And actually, and the modern, uh, how the modern IT system goes, and internet and all of these things, artificial intelligence and so on and so forth. All of this depends basically on the requests which the user does. So that's who is everything is dependable on. Now, talking about the hardware, well, without hardware, you cannot have anything what we do today. None of the operating systems, none of the applications we're using, either the internet and all of these beautiful things. So all of these three components, obviously, they work together. Okay, they're matched together and they work together. So commonly, once again, we know as hardware, software, and the user itself. Now, if we would like to go and define more of this, which are interested, especially in the light of what we're going to do today with the virtualization, and we're going to speak a little bit about the cloud as well. It's important you guys to understand. Let me, if I need to speak about all of this, you see, the hardware is what we're starting with. Now, when we start from the beginning, from the bottom, right? This is the hardware. If I need to remind you very fast something which you've done when you started the course, actually, I don't know, a year and more ago, we have our computing system, any computing system, even in the embedded computing systems, which are basically the major function of them is not to be computers. They're fridges, they're toasters, they're cars and space stations and stuff like that. So the actually computing system inside helps users to use the major facility, the major purpose of the system to be used. So basically, even for them, you're going to find out the same components. You're going to find out the CPU, the central processing unit, or the processor, which is the brain of the computer, which actually does very simple things, but it does them very fast. It is calculating anything what the system asking to do, and afterwards giving orders who to do what and in what order. That's basically what it does. And actually it doesn't do this. The kernel of the operating system, something which we're gonna speak after, will do this for it. Okay. Now, getting back to the hardware components, we have always a CPU. This is the CPU at this moment. We have we have also kind of memory there, storage there, and we recognize two type of storages. The first type is the volatile or non-persistent storage. After the reboot or restart of the system, the content of this is wiped out. It's not anymore there. And you have the non-volatile or the persistent storage, which actually we use to store our information on. These are for the persistent storage. Obviously, we have the hard drives, we have the flash drives, we have the the SSDs, which are very close to the to the flash drives, the solid state drives. We have the CD, DVD, Blu-ray, with even there are some which have two layers on them, two sides, for more information to be gathered, and more and more. So that's what is the persistent. For the volatile or non-persistent one, we're talking about most of the time about the random access memory and any time of caching as well, which we're using. These are the type of memories which allow us very fast. They're very fast comparing to the non-volatile one, but indeed they're actually very they don't persist after a reboot. So you know all of this already. You need the motherboard for sure, where all the components are hooked. Most of the motherboards, they have a lot of components which are pre-installed there, but also you have extension slots which you could use if you would like to add some more additional cards, like if you need a second network or third network as well. Well, you could add a network card, or if you need a better video, you could use a video card, and so on and so forth. You need the power supply for sure, so to have the power, and you need a case. So we are talking about system which could be client system, most of the time used by the clients and with the client operating system, which most of the time are small sizes, and you have the bigger and more professional and used for server systems, which are used for servers. We know what's the difference between the both client and server and how they interact. So you have the peer-to-peer communication, and you have also client-server communication. All of this, they work this way. So basically, you have also a case in which you could put all of this. And if we are talking about embedded system, it could be very big and very small. And as we said, it would be something which not primary purpose is the computation. It's something else. So that's a very, very short recall of what you've been doing before. Additional moment here is you have lots of connectors, and which actually all of these devices connect to the motherboard, and actually to connect to the motherboard they use slots most of the time. So it's these slots you have here. Now the slot itself is just the connector which is put on the motherboard. Indeed, after this on the motherboard itself you have circuits which actually they have implemented inside kind of logic, which connected through the motherboard, actually speaking with the RAM, with the CPU, the RAM, and the other components will do the computer, the hardware section to do its job. So that's what we were talking about when we start talking about the hardware. Now there is a small component here, so let me go and show it to you again. It is you have something which is called a firmware. Now they use a separate term for this because it's a part of the hardware, but it's also have a lot of logics inside. So there is a programming there, low level programming, and I would say with a very very close very very closely to the truth if I say that they have kind of operating system actually in these chips. So the firmware, it is operating system which actually helps the real operating system we use to start. Well, helps the hardware healthy to start. So actually what it does through the BIOS or nowadays also UEFI, here you have the basic input-output service, which is the legacy service nowadays considered, and you have the UEFI, which is the newest way, the Unified Extended Firmware, or sometimes you could hear it only EFI as a extended firmware. It is okay in both cases. So I just remind you guys that nowadays most of the time you're gonna use this one. Okay, but both of cases you're gonna hear people to say BIOS, right? Because it's still, it has been used so much, so people are still stick to it. But most of the time, I have actually here a small NUC computer which I'm having. It has no legacy. If I would like to install a legacy system, I cannot. I just need to configure everything for UEFI and to use it like this. So very often most of the devices will be like that. So actually the bootloader, which is a very small program, which starts after the post is done. Okay, and so the power on self-test, that's the first stage when we're talking about any BIOS, what it does. So the first stage will be the power on self-test. Then you're gonna have the CMOS, which have two components. CMOS is the chip itself on which you have the BIOS put it, or once again UEFI, and it is also the logic switches behind, which have normally the system setup is called. So the chip itself, the CMOS, is called complementary metal oxide semiconductor. That's why it goes, and that's the physical part. The programmable part, so these are the menus when you go to the BIOS and the UEFI, when you click on it. Well, the programmable part is normally called the system setup. Okay, so that's how you know both of them. So the device controllers and the connectors are, I already spoke about this. These are the connectors which are connecting the slots to the motherboard, and actually they interact with all of this. So this is the third part of the BIOS or UEFI, or I would say BIOS again. I'm going to use firmware part. Now, when you start the computer, when you physically click on the button, depending on the system, there are a couple of steps which the system does. Well, the first one is the post. It's checking. It's the power on self-test, meaning checking the system. The system checks itself. So checking all of these controllers, which the system cannot work without. So as soon as everything is done, the system will start. If you remember, if something's wrong, actually you're going to hear, depending on the system again, producer, a series of beeps. And actually with these beeps you could find out what is not good. Most common problems are there is no keyboard connected, RAM memory is loose, or something even more dangerous kind of could be done. So, but most of this could be troubleshoot by the beeps which during the post process will produce. If everything is fine in general, there are more steps, but if something happened in general anyway, what is interesting then it is that the system itself will start the bootloader. So it depends. If you have Windows 7, it was a 1, or XP, it was a 1 bootloader. And the modern operating system, the Windows bootloader, is different than the other ones. And it's very, very different than the Linux and Unix ones. Most of the time it's called grub now, grub 2. So the Grand Unified Bootloader is also called. So this thing actually is a small piece of program which helps the system to start. Okay. Now, when we are talking about MBR and when we are talking about GPT, so you see, MBR is related with the BIOS, the legacy system. GPT or grid partition table is connected with the UEFI. So they goes side by side. If you use GPT, it's UEFI. If it's MBR, it's BIOS. So master boot record and the partition table is actually where the bootloader resides. And these are logical paths which are physically put on a small partitions into beginning most of the time of the hard drives. So that's what will happen during if the post process is done. Well, actually, it will be triggered afterwards, the system to start through the bootloader. I'm not going to go in more details. There is no need for this. I just recall you the most components because we're going to speak about them after this. Okay? So if I go to the next slide, actually, the next portion of all of this thing is the operating system. Now, we said once again, we're talking only here about the operating system, kernel, applications, all of this. Majorly, this is the software. Okay? So the software, if you look at it in general, now you have the software in general perspective of the let's say general perspective of having the applications which are mostly what the users are using. So it's a user portion of the whole software thing, and you have also the portion of the system or system software, I would say, or system part of the software which actually the system itself supports itself like. Okay, so the system to work, it needs a system portion, and the user to use it, they need the application portion. So some of the some of the applications, actually, as you very well know, you could create yourself by users, as you as users. So basically, you could install programs, you could use them like creating documents, creating videos, music files, I mean audio files, and so on and so forth. The applications you use, obviously, they're part of the software portion or system portion of the software, because you're supposed to install it, and it will interact with something we call the kernel after this, and the operating system itself. So basically, that's why the whole thing here is called software, but we we virtually divided it for several sub-layers, I would say. Okay? So the operating system itself is the most important component, so the user to be able to use the applications and actually to do what the hardware is capable of maximum, and to be satisfied at the end, doing either his or her job, or doing entertainment or something else. So basically, the operating system itself, there are three major operating systems nowadays: Linux, Windows, and of course the Unix, with the most important representative nowadays, the OS 10. Right? So basically, the operating system itself has a very important component, which is kind of program as well, small program, but very, very important one, which is called the kernel. Now, the kernel itself is a mediator in between the hardware and the operating system. So we know that the operating system using something which is called drivers to communicate with the hardware itself. So what the drivers, they are small programs which are within the operating system. You install them as an operating system, and actually they act with the they speak with the hardware very, very very intensively. So actually, if you have NVIDIA video card, well, you need a driver for NVIDIA, especially for the operating system of Windows 10 if you use. Now, if you change the operating system to Windows 7, well, you're gonna need a new driver. So the drivers are very, very dependable of the operating system, of provider as well, and of many, many other factors. Now, before this, I would say 5-10 years ago, it was a huge nightmare finding out drivers and preparing your system in the state you want to be, like Windows XP or Linux, let's say 7, 8 years, 10 years ago. Nowadays, all the providers, actually, they provide the major software or operating system providers with their drivers, or the operating system providers were able to implement most of the drivers into their operating system. So basically, that's why when you install an operating system, doesn't matter which today, basically all of them are finding out the needed driver. So nowadays, maybe if you're gonna have a specific model of printer, scanner, camera, or something much more, let's say, not common in use, you're gonna need a driver for this, which you could download right away from internet. So that's what the driver is, and they heavily interacts with the hardware. Okay, they stay on the level of the kernel in between both. Okay, now we set the drivers there for the CPU, RAM, and all the devices. Right, we set these are all the devices which I just explained, which could be. Now, you have also, in the level of the operating system, you have programs. Let's open here the next slide, actually. By the way, the shell, what you see here with the dashed black line around the kernel, well, the shell, it is the interaction between the operating system, and it interacts in between the operating system and the user. Actually, here it is, interacts between the kernel and the user, more particularly of the operating system, the kernel. Now it has the command line interface, and that's the graphical interface nowadays as well. So that's what is the shell most. I mean, there are other things, but that's the most prominent thing which we mentioned. Now we said, if we go to the next slide now, you're gonna see that that's a little bit to remind you the file systems. So the file systems actually are important when we were talking before about the BIOS and the UEFI. So when we have BIOS, we said we have the master boot record and GPT, but also the organization of the hard drive and what the capabilities of the hard drives we use, or in general, if we're talking about the the persistent memory, basically it changes using either the BIOS or the GPT. With the GPT, we could have much bigger partitions nowadays. We could have information and use directly from it. So basically, the file system is what allows us to do this. So if you remember, the practical review of this is when you put a new hard drive or new SSD or any drive on which you would like to put an operating system. Actually, it's asked you first to format this carrier, so you guys to be able after this to put the operating system on it. And as you remember, there are different type of file systems which suits differently with every different operating system. So if you remember, NTFS we use only on Windows, X4, XFS we use in Linux, ZFS and some similar we use on Unix, and so on and so forth. So there are many of them, and that's not the topic, but you just need to recall that there is such thing which is important to remember, right? So also interesting. So also just to remind you that there are programs. Here it is, programs, also called applications, software also. There are processes, jobs, tasks, services, also called daemons in Linux and Unix, signals, all of this which works in the software portion, here in the application, operating system, and the kernel as well. So I put it here a little bit of explanation. The executable file stored on some kind of a storage, most of the time we call a program. Okay, and you know what the file is. We already said a file is collection of data which is stored in one logical unit and organized by similar purpose. Okay, and it is defined most of the time by file name. In Windows operating system, together with the file name, you also have, if you remember, an extension as well. So it could be a document, it could be picture, audio, video, data library, like libraries in which the system using in operating system using in Windows, Linux, Unix, and so on and so forth. Well, the DLLs libraries are mostly used. They're used in Linux. In Windows and in Windows, in Linux and Unix is defined via configuration file, which most of the time are text file. But anyway, it is a form of a unit which organizes the information in by a similar purpose. Okay, so when you load the program into the RAM, actually it becomes a process. So the process indeed is a running instance of a program. Okay, so the program is a static object, guys. It's that's how actually the program could be opened a couple of times. So instances of the programs called processes will be open. Okay, now the processes which are started by the operating system, which waiting into the background for a request, are called services, system services. And in Linux and Unix, they're mostly known as daemons. Okay? You could hear it as daemon as well, but daemon. And that's why you have some of them, not all of them, but some of them called like D at the end, HTTPD, firewall D, and so on and so forth. That's where it's coming from, the D. And the system call is a process that makes requests to the kernel, actually. So this is an active portion of this, right? So it's not waiting anymore. It is interacting with the kernel, and in this case, it's called the system call. Now, it is once again not the primary reason for what we are doing here. So that I just mentioned it, I put it here so you to know where exactly they exist. Okay. Now, yes. If you try to. So all of this was just introduction me to start with the hypervisor. As Chaitanya just mentioned, these are the hypervisors. So we're going to speak about type 1 and the type 2 hypervisors mostly. And the difference between them is that the hypervisor type 1, it is because it's installed as an operating system. Okay, so actually you have the bare metal, or the hardware also called, hypervisor, which is installed as an operating system, and then you start installing sub-operating system inside. Okay, now with some of the hypervisors you could go even further. You could install another hypervisor inside, and you could start installing virtual machines inside this hypervisor too. This is commonly known as a nested virtualization. So you have a virtualizer in between, virtualizing within the virtualized, or hypervisor within the hypervisor. Now, when we're talking about the hypervisor, this is the program which kind of tricks the operating system and the kernel specifically, that the small files you produce are not files indeed, they're actually virtual machines, separate virtual entities. So that's what the hypervisor does. Okay, so if you come here, so having a CPU, processor with virtualization support is crucial for this thing, because otherwise you cannot start it. It won't work. Now the good news is that 99.99% of what's produced, not only servers but the clients as well, they have this. So it's nothing fancy. Now, if you need to do nested virtualization, this means it's supposed to be allowed in the virtualization itself, and I'm going to show it to you. In comparison with VMware and VirtualBox before, let's say 2 months before, where the VirtualBox allowed it to, only VMware player, they were having this. So that's why I actually do all of the exercises which follows, since it's still the better. I'm doing in VMware in our case. I'm not gonna do them in VirtualBox, although you could try, no problem. Okay, so now the type 1 also allowing the clustering, or it's combining the resources of more than one physical system throughout the network, or even if they're geographically dispersed. So what that means, if you have a couple of systems which have the hypervisor installed on them, like ESXi in our case, that's what we're gonna do, and with XCP-ng as well. So we're gonna have 2 physical machines, which we're gonna say physical, but they will be virtual in our case. And then we will install hypervisor on the first one, hypervisor on the second one, and then we will combine them, and we're gonna see all the resources by clustering them. We're gonna create a cluster, and we're gonna organize both of them together. Okay, that's very, very cool technology, very nice thing, and you're gonna see it. You're gonna see it there, guys, when we start doing it. So that's what we refer most of the time as a type 1, or also it is called the bare metal hypervisor. Okay, that's what we refer. The general thing to remember, it is installed as an operating system, so you don't need an operating system, a separate one. The other one, which is the hosted, also called, or type 2 hypervisor, it is called the application. It is called hypervisor type 2. Okay, it's commonly known as these 2 terms, and it is used the free system resources to emulate separate computer instances, also called virtual machines or guests, with the purpose of testing different concepts or operating systems. You know that what we do, that's all the time. We have our laptop, we have our Windows on it, we install VirtualBox, that's the hypervisor too, it's installed as a program, and afterwards we start using the virtual box manager, which is the virtual host or also hypervisor. We start creating inside files, which are our virtual machines. So we use the spare resources of our real computer, of our host, so to make our life as IT students at the moment easier. That's what we do. Okay?
This type 2 hyper.
Something which I would like to as you see here, it says that is used mainly for testing and logs, but you could use it also kind of production. If you need a DNS server, well, no problem, you could install in VirtualBox. It's stable, it will work, but you need the host to stay awake all the time, right? So another thing which is commonly misplaced, but it's not the same, it is the container. Now, before Docker, which is the most used nowadays containerized thing, we had different type of containers before, okay, and we still have them. But the Docker, as I mentioned, is one of the most used nowadays. So The container, don't make mistake to say this is a virtualization. It's not the same as the type 1 and type 2 virtualization. To have the container, first of all, you need the operating system. So it always goes with the operating system. Afterwards, you need something which is called a container engine. You see, I put it here next to the hypervisor. And then when you have this container engine, okay, then you will create a container, or you're gonna download an image actually, and then from this image you're gonna start a container. You could create your own image as well, okay. And this image actually will be a virtualized application. So it will have inside portion of the operating system exactly as it needed this application to work. Okay, so that's the difference. It is not installed on the hypervisor. There is no hypervisor there. Okay, it is installed on a container engine, which is installed over as an application. I would say it is installed over the operating system. Most of the time, that's what it is, the container. So don't misplace the both things. Okay, that's important to know. Speak about the type of providers for type 1. You have the VMware, we said that's the most used nowadays in production, and ESXi and vSphere also is part of all of this thing. ESXi is the part of virtualization, and that's the technology we're going to use hopefully here. Now another one is the Microsoft with its Hyper-V. As you know, starting with Windows 8, even in the clients you have this thing on. Okay, but if you remember, and I'm going to speak then, I will explain you more in depth. You guys cannot combine type 1 and type 2. So basically, if you would like to have Hyper-V and VirtualBox working together, remember there is a small hack. You need to do your system dual bootable with this, and afterwards, eventually, after rebooting, you could use Docker. If you would like to use back VirtualBox, you're gonna reboot and you're gonna use the system without the applied virtualization, without Hyper-V, and you could use the VirtualBox then. So that's the Hyper-V. And Hyper-V, of course, there are two ways to be implemented. You could install it as a role on the server when we are talking about you know, the production instances of this. So it is a role of the Windows Server system, starting with Windows Server 2008, as well as you could install it as a separate operating system as only Hyper-V. But in that case, it has no graphical interface. You need to use PowerShell, and you need to use the hypervisor manager remotely to access it, which is kind of easy to use as well. Now, another very popular one is the KVM. Okay, the KVM, the kernel virtual machine, as the name implies, it's not only the hypervisor itself. It's part of the kernel which does even additional things. Kernel virtual machine goes together with QEMU. Okay, indeed, QEMU was the first which has been created. Now, I put it QEMU here in type 2, but it's not exactly the same. I just would like to make kind of differentiation, but that's not exactly what it is. Nowadays, the system actually are known as KVM-QEMU. So both of them, they work together, and they work on the level 1. They are on the type of the under the operating system. Even though you're going to install Linux and you're going to allow after this the KVM to work, it's a type 1 hypervisor because it's working directly with the kernel. And once again, it works together with QEMU nowadays. QEMU was the oldest technology. It was the first one created. Now, the Xen is very important representative of the virtualization. The Xen server started as a free project. Afterwards, Citrix created on top of it and start virtualizing applications, and they were working with Windows, and they still work with this. At certain point, even though it was the Xen server, the whole thing was open source, well, Xen started closing modules. That was about 2 years ago, so a lot of programmers, specifically from Europe, they who already had the code, the open source code, well, they start creating their own Xen, which is the XCPNG. It stands for Xen Cloud Platform - New Generation. That's what it stands for. So it's a Xen with new capabilities and open source. Most of the things you're going to see, which I'm going to show it to you, while we're doing the labs, they will be free. Okay, they will be open source and free. Now, the Cubes OS, I put it here because you guys are in a kind of environment where you know you use a lot of technologies. By the way, Zen most of the time is used to make something which is called application or desktop virtualization. The virtualization which I was talking up to now most of the time is called hardware virtualization. So basically the system, the hardware system, the RAM, the CPU, and all of these resources there, the network, the hard drives, they are virtualized. When we're talking about Zen, it's kind of very closer to containers, but it's not container, right? It is portion of the operating system and application virtualized, but on the hypervisor level, or they could go even further. They could virtualize the whole desktop. Okay, so the whole desktop thing could be virtualized, and that's most of the time known as thin client. Okay, you could find out something in the production. That's how it works. So cubes here, I'm talking about this one because you as students from the networking security, this is one of the most secure operating system nowadays known. Okay, the learning curve is a little bit steep, but it is amazing product, and it is based on using Zen. So you install a Zen hypervisor type 1, and afterwards on the top of it there are installed applications, virtualized applications using Linux components there. Okay, so it's combination of all of this type 2, type 1 containers nowadays also they do. So all of this it is here, and it is really a really secure operating system which everyone could enjoy. Now Proxmox, open virtualization are very, very important. Now Proxmox, by the way, goes a little bit further into the cloud instances, something which I'm going to add after this. So the cloud is when we are able to conglomerate, when we are able to create, to organize, to cluster the thing locally, I would say, mostly locally. If you have a geographical dispersion of this, then we start talking about the cloud. Okay, and we know which are the major cloud providers nowadays. We're talking about Amazon, AWS. We're talking about Azure of Microsoft. We're talking about Google Cloud Platform. We talk about Alibaba. We talk about Rackspace, and others you could find out. Now, most of these are paid ones, and because they provide you resources. Actually, you rent. That's what it is. The cloud. You use resources which are not yours for a specific time, and you pay for them. Well, it is mostly known as public cloud, since your infrastructure will stay somewhere on some people premises. Now, if you create your own cloud on your own premises, it's known as a private cloud. Most of the time, most of the companies actually they combine both things, and which commonly is known as hybrid cloud nowadays. So you use both resources depending of what you do in your company. Even at home nowadays you use both. Now there is also a public cloud you could install, and you could actually sell for other people or use completely for your purposes, which is completely free, and it is called OpenStack. All the major Linux distribution nowadays, they have even certification for it. I'm talking about Red Hat, I'm talking about SUSE Linux, Ubuntu, and so on and so forth. So this is something which is virtualization multiplied by geographical location, right? So if you have several offices or data centers in different geographical location, dispersed on different continents even, well, that's when we're talking about the cloud. Okay, so that's why the virtualization actually is the base for today's cloud, combined with the internet, of course. Okay, so I haven't mentioned it here, but I just do a recording of it, so you guys will know after this about. Now, the Type 2 once again is installed as an operating system. The major provider again is VMware. Okay, the free for non-commercial and educational use is the player, which we use it. Okay. Now, if you're going to use it for, it specifically said this, if you're going to use it for non-educational purposes, for production, you need to pay it. Okay, you need to pay for it. So workstation, it has actually for Microsoft, you have two major distributions. You have Workstation and Workstation Pro. They're the best if you would like to do your virtualization lab and to do many things. It's the easiest way and the best way to work. Unfortunately, you need to pay. Well, not unfortunately, but you need to pay. And the Pro is a little bit more expensive than the other one. It's about 300 American dollars. Now the Fusion is a kind of workstation which works on the Mac. Okay, and it's payable as well, but it's cheaper. It is the cheapest comparing to all of them. Now the Oracle, in the beginning it was Sun, actually, and Oracle bought them. So VirtualBox is the Oracle product. 2 months ago, as I mentioned, about 2 months ago, with the 6.1 version of VirtualBox, they allowed the nested virtualization. That was a very important thing. Before this, we were able to use it only on VMware. Okay. Now Linux, I spoke a little bit about the QEMU here, and there are others like Vagrant is one of the most prominent one. I haven't been with you in this lab, but actually we use in one of our hacking labs there, we use something which is called Metasploitable. You have the Metasploitable, which is the victim, and you have the Metasploit, which is actually the aggressor, which attacks the victim. So when you would like to have this instance, nowadays the version 3 of it, Metasploitable 3, you're gonna find it as a way you guys to install using Vagrant, because actually Vagrant actually automatize the installation of so you're installing it by automatically. Because it's kind of complex installation, so there is a script which actually combines all the components and install everything for you. Well, once you have your virtual machine installed, actually what you do, you export it afterwards as a VDI, and you don't need to do this anymore. So that's what I did for my students. I did it myself, and afterwards I exported it to a virtual, as an instance of VirtualBox, and then I shared with everybody, so everybody was able to, without any installation, to use it. But the Vagrant is, that's why they use it. It is something which automatizes complexes or lots of virtual installation if you need. There are more, okay? So that's the most important part, which says a container and or also type 1 hypervisor cannot be combined with type 2 hypervisor. That's not possible. And that's why, guys, you have the GNS3 virtual machine. That's the reason for it. Okay, because if you would like to create your GNS3 infrastructure, and in this GNS3 infrastructure you have things from QEMU. Most of the time, these are the let's say the firewalls like ASA we did, or you have networking devices we're using from the viral up there, the routers, the switches, and other things which are installed there through the QEMU, like the Firefox machine, if you remember. And most of the things you're gonna download actually from the GNS3 marketplace. Most of these, they're supposed to reside either on a separate server, remotely located, remember, in your local network or somewhere in internet, or you need the virtual machine, the GNS3 virtual machine. Nowadays, the GNS3 virtual machine could be installed on Hyper-V, on VirtualBox, because it supports already the virtualization. Classically, when you use it on the laptop or desktop, we use the VMware player because it's free, right, for educational purposes. And I still will use this in our thing because it's working best of all of them. You could install it on ESXi as well. Okay, all of this you could use so to install it. Now, if you would like to combine it with the VirtualBox, the same is with the Docker. If you install Docker container, it won't work with the VirtualBox because Docker in Windows needs Hyper-V. It works with Hyper-V, over the Hyper-V. So in that case, it won't work with the VirtualBox. So you to avoid all of this, because if you remember, most of our servers, our firewalls also, OpenSense, pfSense, all of this we install on VirtualBox, and afterwards we import it into the GNS3. So VirtualBox, which is hypervisor type 1, to work with the QEMU and KVM, which are the viral switches, routers, and so on and so forth. Everything from the GNS3 marketplace, which is hypervisor type 1. We need the GNS3 virtual machine as a mediator. That's why we use all of this. I hope now it's clear, this thing. Okay, and here's about the GNS3. It is It is used as a bundle hypervisor, so very close to the real infrastructure simulation to be done. And as I mentioned a couple of times, the program has Cisco Packet Tracer and it emulators, which means they don't allow the usage of the virtualization component there for infrastructure simulation. They're predefined in a way. So that's why using GNS3 is much better than using the packet tracer, I would say. And there is another one, notice here, which the paid Cisco Viral Virtual Internet Routing Lab, indeed is the best one, which is virtual, as you see here. Virtual is the most important thing. It costs $200 per year subscription. You could do everything on their virtual labs remotely. Okay. Otherwise, the best thing to do your labs, of course, is the real hardware. That's what it is. But if you don't have it, GNS3 is the best option. Okay. So the GNS3 virtual machine, that's the additional hypervisor type 1 or 2 with CPU, and nested virtualization supposed to be here, obviously, because you need the hypervisor installed there, and within it to put the other components. And it is used to handle the type 1 virtual machines. And as I mentioned, VMware is classical. Don't forget 12. It doesn't work with the other option when we're talking about player. If it's a workstation, it will work with the latest version, no problem. But with the player, it works only with this one. And you need something which is called VMware VAX. This is the library which actually is missing because this product is free. So you need the VAX library so everything to work together. VirtualBox after version 6.1. So if you need VirtualBox to do nested virtualization, download something which is bigger than 6.1. Okay, ESXi Hyper-V, and of course remote LAN or WAN, mostly on Ubuntu server. Now if I need to show it to you something like this, here it is. I'll show it to you on my local network. So I'll open this GNS3. We started. You see it here. The remote is my remote desktop, my remote server, on which I could put, I could create networks without any problems, and I could create infrastructures there, and I could actually combine all of this. But you need to be very cautious because you need connectivity in all of them. So it's better when you choose a carrier, either the GNS3 virtual machine or the remote CPU, well, to work with one of them. It's best this way. Okay. So basically, you will see it now. It will start. Here's the GNS3 virtual machine. It will become green. And I'm using actually the latest, the very latest one, 2.2.8. I upgraded it 2 days ago when it goes out. So here it is. That's how it looks when you have GNS3 virtual machine and when you have also a remote server. Once again, remote, but it's in my network here. It's a separate computer. Okay. Already part of this, but the type of virtualization commonly known today are hardware. That's the type 1 and type 2. We said we virtualize the processor, we virtualize the hardware, we virtualize the network, we virtualize the RAM, you virtualize all the components you choose from the VirtualBox, let's say. So all of these are combined. Now you have also a network specifically called, it's a little bit different. In the hardware type we virtualize also the network, but this one is a little bit more advanced based on the networking. Nowadays, with the new content which started February with Cisco, they heavily, point to this, on this, plus of course, heavily point to this one, plus adding, of course, the Python as the programming environment. You could do all of this software virtualization. Is commonly known nowadays as a software-defined network, or SDN. Now, the storage as a part of the virtualization is very, very common and very easy to be done nowadays by combining millions of storages as clustering them, okay, with a lot of different levels of, combining all of this and creating virtual and physical volumes and partitions and so on and so forth. So nowadays there are data centers which are just data storages actually. So they don't do anything else than storing data and interacting with other data centers which actually taking and using this data all the time. So there is also a type of virtualization which is based on containers. the application one. As well, we mentioned that desktop virtualization could be part of it. We said Zen, Citrix, these are the people who are doing this, and the Docker, of course, and the other container technologies. And if I need to, so that's what I wanted to say about the virtualization, clouds, and containers in general, and all the other topics. You got very basic computers component overview. You learn how the computing devices is virtually layered, what is the hypervisor, virtual machine, container, and the most relevant ones. Initial view of the GNS tree, and not only initial, we apply our knowledge there to understand the connection in all of these components, and learned about type of virtualization which exists nowadays. And we could start now with installation, obviously.